Welcome to the third video in the series of videos of current electricity. In this video we're going to talk about the idea of potential difference. To better analyze, let's take a simple circuit. Now in this circuit you have a bulb and a resistor, and both are resistors, and we talk about these values of what it means in the next video, but let's assume these numbers, the 10 and 10, represent these values represent the resistance, or this quantify the amount of resistance that this offers to the flow of electron. And this is a 9-volt battery, and this can, let's say this can deliver any maximum current. Okay, usually that's what we assume. It can deliver anything. Now over time this battery is going to give out about a coulomb of charge. It may take a lot of time, but let's say for over a long period of time it delivers 1 coulomb of charge. So the 9 volts, it implies that for that 1 coulomb of charge, how much ever time it may take, the battery gives an energy of 9 joules. So 9 joules per coulomb. So the battery gives energy for that 1 coulomb, which is 9 volts. And as this coulomb passes through, though when I say passes through, it sounds as if this 1 coulomb is passing through together. In reality, this 1 coulomb is passing through this wire over maybe an hour, or maybe half an hour, I don't know. But we are analyzing that 1 coulomb as a unit. So as it passes through this resistance of 10 ohm resistance, so we usually denote this by R1, and bulb also has a resistance, so we denote this by R2. So as this 1 coulomb of charge, by the way, I must also mention that we are going to use the convention of current direction and not the electron direction from here on. So we will assume that the current is moving from positive to negative, while in reality what's happening is the electrons are moving from negative to positive. So with that caveat, as this 1 coulomb passes through the R1, it probably, since these both are same 10 and 10, it loses half its energy, so in the form of heat. So it loses about 4.5 joules per coulomb across R1. This is across battery, right? You label everything, and as it passes through the next resistance, it loses another 4.5 joules per coulomb, right, through R2. So in general, we can define the potential difference as energy gained or lost per unit charge, per charge, right, between 2 points. Right, so this is joules per coulomb. So this is actually your potential difference, and this is very important to understand it this way. And if you understand it this way, you will never have confusion in current electricity. So let's take one more scenario a different scenario where these resistances are different. So let's say this resistance is not 10, but this is 20 ohms. This is about 20 ohms, and this is 10 ohms. So in which case, this is dividing up in the ratio of 1:2. So I urge you to pause the video and try to imagine what would be the energy loss ratio of R1:R2, and how much energy would be lost across R1 and how much across R2, by the simple fact that the resistance offered are in the ratio 1:2. So pause the video and give it a try. So basically you you want to divide 9 joules into 2 parts. One part is 2 and the other part is 1 unit, right? Because one resistor, this R1 gives, R1 is to R2 is in the ratio 2:1. So that means that R2 would be 6 joules, it would lose 6 joules, and R1 would lose about 3 joules because it's lesser resistance. So this is about 3 joules and this is about 6 joules. In other words, we say that the potential difference between these 2 points is 9 volts, and the potential difference across these 2 points is 3 volts, because every coulomb that passes through loses 3 joules, and the potential difference across these 2 points is given by 6 joules in this particular 6 volts, right? Which is, for every coulomb it loses 6 joules. So this is a way to interpret potential difference. I know in your textbooks and etc. you have definition of volts as work done per in moving a unit charge from infinity to that point, etc. Now those definitions are valid in electrostatics. Since we are not doing electrostatics here, we are dealing with current electricity. I urge you not to worry too much about it until you study about electrostatics in higher level. So I hope you enjoyed this video, and see you in the next one.